We are talking about a couple of new formulas today, and then we're actually going to use one of the skills that we were literally just practicing on our starter, Pythagorean theorem, to classify triangles. Okay, I bet you didn't know that you could actually classify a triangle, the type of triangle it is, using the Pythagorean theorem. Maybe you did. Okay, but the first thing we are going to identify is finding the distance and midpoint between two coordinate points. Okay, raise your hand. I remember doing this. I've done the distance formula before. I've done the midpoint formula before. Yes, I love it when it's all new. Okay, so turn your paper over, because we got some formulas to write down. Okay, remember, we love formulas, because formulas just tell you what to plug in. Okay, all you gotta do is find what to plug in, boom, you're good. Okay, so the first one we're gonna talk about is our distance formula. Well, okay, so our distance formula, it's actually going to look kind of familiar to the Pythagorean theorem. It's very closely related. Okay, so we say this is d, our distance, equals, you're going to give yourself a big square root, because there's a lot that needs to go under this, the square root of our second x coordinate, subtracting our first x coordinate. Okay, close parentheses, that's the first little piece. And then it is being added to our second y coordinate, subtracting our first y coordinate, close parentheses, and I almost forgot a very important part of this, is that each one of these pieces are also squared. It looks a lot meaner than it is, okay? Who remembers the slope formula? y2 minus y1 divided by x2 minus x1. That one's not bad. This one's closely related, right? We see our x2 minus our x1, y2 minus y1. Again, very closely related. This time we're just not talking about slope, we're talking about how far these points are from each other, okay? So that's our first formula we're gonna talk about, okay? And in fact, while that one's fresh in our brain, turn your paper back over. Okay, because our first four, that's what we're using. Okay, so we are going to be finding the distance between two coordinate points. Okay, so let's go ahead. We are given a graph. So what do you think we need to find on this graph first? If I need to know the coordinate points, what do I need to do with this graph? Carl?
Find where the points are.
Find where the points are, right? It's not telling us what these coordinate points are. So we're going to have to find those ourselves. Okay, let me get a different color. Okay, so that means I need to identify what this coordinate point is and what that coordinate point is. Ooh, who can help me out? Okay, let's do this bottom one first. What is this bottom coordinate point? What do you guys think? What does it line up with? X, comma, y. What do you get, Coulter?
-2 and -3.
Love it. That guy right there is -2, comma, -3, x, comma, y. Love it, love it. Okay, what about my second coordinate? Who's got my second coordinate, Carl?
+5 and +4.
Switch those around.
Oh.
X, comma, y. We get 4 for our x, comma, 5 for our y. I love it. Always good to refresh, x, comma, y. Okay, so we have our two coordinate points. That's what we need to plug into our formula. Okay, so we know that our formula, let's go ahead and just write it again. Why not? So it's fresh in our brains. Okay, remember, the better notes you have, the easier your test is. Okay, so we have x2 minus x1 squared plus y2 minus y1 squared. Okay, and all we need to plug in are these x2s, x1s, y2s, y1s. And all that really means is the second x coordinate, the first x coordinate, the second y coordinate, and the first y coordinate. Alrighty, so out of these two coordinate points, you guys, which one do you want to be your first coordinate? I don't care. Which one do you want to be the first one? Leo?
4 to 5.
Sure, why not? That means this guy is x1 and y1. Why not? Okay, well, if we chose that as our first coordinate, this guy's going to be our second coordinate. In other words, x2 and y2 are those guys down there. Okay, well, now we have everything we need to plug into this formula. So let's go ahead and do it. Okay, you're probably going to need a calculator today, so if you don't have one, go grab one. Okay, so we have our distance formula now. Equals the square root. Okay, my first parentheses, x2 minus x1. We chose x2 as negative 2. Minus my x1, positive 4. Squared. Plus y2, we chose negative 3 as my y2. Minus 5 as my y1 squared. Okay, literally just plugging this into the formula. Okay, now let's just crunch some numbers. Starting off with inside our parentheses. What is negative 2 minus 4? Negative 6, okay, negative 6. That's going to have to be squared in a second. Plus, okay, what's negative 3 minus 5 in my second one?
Negative something.
Negative 8 squared. Beautiful. Okay, let's just keep going with these numbers. What am I going to get with negative 6 squared? Think negative 6 times negative 6.
Negative 12 or negative 16?
Positive 36, right? Negative times a negative gives me a positive. So positive 36 plus negative 8 squared. Positive 64. Okay, let's keep going. I'm not bringing my square root down yet. This is just all still inside the square root. Well, tell me, you guys, what is 36 plus 64? 100. Look at that. We literally took all of that mumbo jumbo, turned it into 100. Now all we need is the square root of 100. It is 10. So our distance between these 2 points is 10. Now that came out to be a really pretty number. Do you think all of them are going to come out to be that pretty when we're dealing with the square root? No, definitely not. Okay, but this one was really nice. So our distance between those two guys was 10. Not bad. Just identify the 2 coordinate points, plug it into the formula. Boom, you have how far those points are away from each other. Okay, let's try that again. Let's look at number 2. What was the first thing we did with this graph? What did we have to identify first? The coordinate points. Okay. Who's got this guy right here? We'll call him our first guy. Leo?
1 and negative 1.
Beautiful. We got positive 1, comma, negative 1 for that guy. Who's got my second coordinate point? Leo?
5 and negative 5.
Beautiful. We got positive 5, comma, negative 5. Alrighty, well, I already said that the first one will do our first coordinate, or the top one we'll choose as our first coordinate point. So that means that guy's x1 and y1, meaning our first coordinate point. And then this bottom guy will be our second coordinate point, so x2, y2, our second coordinate point. Alrighty, we have everything we need to just plug into this formula. Okay, so let's go ahead and do that. We have the square root of x2 minus x1. Okay, we chose 5 as my x2 minus my x1, which is positive 1. That'll be squared. Plus my y2, negative 5. Ooh, what happens when I subtract a negative? Turns into what? A positive. Okay, so the formula is telling us to subtract, right? But whenever you're subtracting a negative, it actually turns into a positive. Boom. Did everybody get where that positive 1 came from? Whenever you subtract a negative, it turns into a positive. Okay? All right. Let's keep going. Let's figure out what's inside the parentheses first. 5 minus 1? 4. So that's going to be 4 squared. Negative 5 plus 1? Negative 4 squared. Okay, let's just turn those into numbers. What's 4 squared? 4 times 4?
8. No.
16. 4 times 4, 16. Negative 4 squared?
Negative 16.
Can you ever get a negative with a square?
No.
Nope, so that's also going to be positive 16. Okay. What is 16 plus 16 going to turn into?
32.
32. So now we have the square root of 32. Is that going to be a nice, pretty number? Definitely not. So this is where you want a calculator. Okay, because in your calculator, you're going to type in second button, little square, well, no. Second button. There you go. Square root 32. Gives me a decimal. That's okay. Okay, let's go ahead and practice rounding this guy to 1 decimal point. What's that going to round to? If I just want 1 decimal point. 5.6 or 5.7? 0.7, right? If we want it to 1 decimal place, you got to look at the second one. You always got to look behind it. 5 and above bumps it up. So the distance between these guys equals 5.7. Booyah. Okay, let's do one more distance formula, then we'll go to our midpoint formula. Okay, so let's go ahead. We have more room for number 4. Let's just do number 4 right beneath it. Okay, let's identify the coordinate points first. We got to know what these coordinate points are. Okay, who's got the top one? Carl?
-5, +3.
Very close. -4, and then up to +4. It's okay. Sometimes it's hard to see. -4, +4 for my first coordinate point. Who's got my second coordinate point? Leo? -2, +1 for the second guy. All right, let's go ahead and use the top one as our first coordinate point. Bottom one is our second. Does it matter what you use for first and second?
No.
No, it doesn't. Okay, so we'll use this guy as our first, x1, y1. This guy's our second, x2, y2. Okay, we have everything we need. Now we just need to plug it in. Okay, the distance is going to be the square root of, okay, we have x2, -2, subtract my x1. What happens when I subtract a negative? Turns into a, good. Okay, so I'm subtracting this -4, which means I'm actually adding 4. Okay, plus y2, 1, minus my y1, 4, squared. Okay, let's go ahead and just crunch these numbers. -2 plus 4, help me out.
+2.
It's going to turn into +2 squared. 1 minus 4?
-3.
So -3 squared. Okay, let's figure out what these guys are. 2 squared?
4.
2 times 2, 4.
-3 squared?
-6.
+9. Because -3 times -3 gives us +9. Ooh, what is 4 plus 9? 13. Okay. Definitely not a pretty answer. There is no perfect square to 13. Okay, so we're just going to take out our calculator. Second button, square root 13. Let's round it to 1 decimal place. What's this going to round to? Carl?
3.6.
Just 3.6, right? There's a 0 behind that 6. So it's just going to stay 3.6. The distance equals 3.6. Beautiful. Nice. Okay, show me a fist of 5 on distance formula. How you feeling? 5, yeah, I could do this in my sleep. 4, feel pretty good. 3s, yeah. I'm getting there. Ooh, I like it. Okay, new formula. So turn your paper over. We are not finding the distance anymore. We are now going to find the midpoint. Okay, now, this is not how far away they are. This is the actual coordinate point that is in the middle of them. Okay, so the midpoint formula is parentheses, because this is how we write a coordinate point, x1 plus x2, so adding your x coordinates and dividing them by 2, We'll give you your new x-coordinate, comma, then add your y-coordinates, y1 plus y2, divided by 2. We'll give you your y-coordinate, your new y-coordinate. Okay, so again, this is not like how far they are apart. This is the actual point on a graph that is exactly the middle. Okay, hence the name midpoint. Okay, we got that formula down. Good to go? Alrighty, turn your paper back over. Let's look at number 5. Okay, well, we're given a graph. What do we need to do with this graph? Same thing we were doing with our distance, guys. Carl?
-4, -4.
Love it. We're identifying the coordinate points. This guy's going to be -4, comma, -4. What's my other coordinate point? Carl?
+4 and +2.
You got it. Beautiful. So again, same first step. Identify your coordinate points. I will tell you on your assignment, sometimes it's really nice. It just gives you the coordinate points. Then all you got to do is plug stuff in. Okay, we'll go ahead, call this guy our first coordinate point, x1, y1. This guy will be our second, x2, y2. Okay, now that we know those guys, we can just plug them into our midpoint formula. Okay, which is parentheses x2 plus x1. Okay, and be careful here. x2, when you're adding a negative, you're really just subtracting. Divided by 2. Then we have y2 plus y1. Again, adding a negative means we are subtracting. Okay, basically you're just adding the two x's, dividing by 2, adding the two y's, dividing by 2. Boom, new coordinate point. So let's take that step by step. What is 4 minus 4, that numerator, going to give me? 0. So we have 0 divided by 2. What's 2 minus 4 going to give me?
2.
-2 divided by 2. Okay, we can simplify this down to get our final midpoint. What's 0 divided by anything? 0. What is -2 divided by +2?
-1.
And there we go. There is our midpoint, which we could put on the graph if we wanted to. 0, -1. That is the point that is exactly in between those 2 points. Midpoint 0, comma, -1. Booyah. Okay, let's try that again. Number 6. Somebody help me identify these 2 coordinate points so I can plug them into my formula. What you got, Leo?
Did we do number 3?
We did not.
3 and -2.
3, comma, -2. You got it. +3, comma, -2. Who's got my second one? Carl?
0.4.
Ooh, very close. 0, comma, up to 5.
Oh.
Got it. Okay, just choose which one's your first one and which one's your second one. I don't know why, I'll just choose this one as my first. So x1, y1. That means this guy's my second. x2, y2. Cool. Let's plug it into our formula. Here we go. Parentheses. x2, 3, plus x1, 0, divided by 2. Comma, y2, -2, plus y1, 5, divided by 2. Okay, somebody help me out here. 3 plus 0, 3. 3 divided by 2. -2 plus 5.
3.
+3 still, divided by 2. Now tell me, you guys, 3 halves. Can I reduce that any smaller?
No.
No.
No. So guess what? We're okay with just leaving it as 3 halves, comma, 3 halves. Okay, which is 1.5, 1.5, up to 1.5. Somewhere right about there is their midpoint. And that's okay. Sometimes you'll get decimals, sometimes you'll get them as fractions, right? They're not always pretty answers. The process is still the same. Okay, we want to do one more midpoint formula? Let's do it. Okay, let's go to number 7. Somebody help me out. What are these coordinate points? Somebody identify. Carl?
-0, -4.0.
Beautiful. -4, comma, 0. What is my second coordinate point? Oh, come on. You can identify a coordinate point.
2 and 4.
You got it. +2, comma, +4. Okay. Choose which one's your first and your second. I'll choose this one as my first. X1, Y1. That means this guy's my second. X2, Y2. Cool. Alrighty, let's plug it into our formula. First, add your x's. Okay, so I got x2 plus x1. Remember, adding a negative really just means you're subtracting. Okay, y2 plus y1, 4 plus 0, divided by 2. Okay, let's do some simplifying. What is 2 minus 4? What's that numerator going to be?
-2.
-2, so we have -2 divided by 2. What is 4 plus 0? 4 divided by 2. We can definitely simplify and or reduce these guys. What's -2 divided by 2?
-1.
4 divided by 2?
Are we subtracting? Oh, dividing them. 2.
You got it. Ooh, that one's nice and pretty. Not bad at all. So midpoint for this guy. -1, +2, which we could put on our graph. -1 up to +2. Boom, there's our midpoint. Beautiful. Okay, show me a fist to 5 on midpoint formula. How are you feeling with that guy? Nice, I like it. Okay, let's go ahead. Last thing we're gonna do today, flip your paper over. There's no formula for this guy other than Pythagorean theorem. You guys know that. In fact, why not? Let's just put Pythagorean theorem up top here again. A squared plus B squared equals C squared. Okay, so that's what we're gonna use for these guys. No, we're probably not gonna do all 6 of these examples for time. Okay, but what we're actually doing is identifying whether these triangles are an acute triangle, a right triangle, or an obtuse triangle. Okay, so if it is a right triangle, the Pythagorean theorem will work out perfectly. Okay, and here's what I mean by that. Okay, let's go ahead and just do one. So let's look at number 9. Okay, somebody help me identify, where's my A, B, and C for this triangle? 6, 10, and 9. We're not solving for a missing side. We're literally just seeing if the Pythagorean theorem works with these numbers. Where's my A, B, and C? Carl?
A is 10.
If this guy's a right angle, it would be right there.
So that's C.
So which one do we want for A and B?
6 and 9?
Sure. Okay, let's test it out. Let's see if this guy is actually a right triangle. If it is, it'll work out perfectly. Okay, so we chose 6 as our A, so 6 squared plus 9 squared equals 10 squared. Okay, notice there's no solving here, you guys. We're just seeing if the answers are equal at the end. You'll see what I mean by that. Okay, tell me, what is 6 squared? 6 times 6? 36. What's 9 squared? 81. What is 10 squared? 100. Okay, what is 36 plus 81? What is it?
117.
Nice. 117 equals 100. Is that a true statement? Does 117 equal 100?
No.
No.
No, it doesn't. So is this a right triangle?
No.
No. What we need to identify now is it an acute triangle or is it an obtuse triangle? Okay? When your C side is less than, so 100 was less than 117, what you got for your A and B, that means this guy is an acute triangle. If your C is less than your A and B, that is an acute triangle. It wasn't a perfect right triangle, it didn't work out. Pythagorean theorem didn't work with this guy. But we can tell it's an acute because 100 is less than 117. Okay, let's try it again. This is kind of a weird concept, so let's practice again. Okay, if this was our right angle right here, where's my A, B, and C for this triangle? Let's see if Pythagorean theorem works out. Carl?
C is 13.
Mhm.
A is 8, and B is 6.
Sure. Okay, let's see if these values work with the Pythagorean theorem. Let's see if this is actually a right triangle. Okay, so we chose 8 as our A, so 8 squared plus 6 squared equals 13 squared. What's 8 squared, you guys? 64. 36. 13 squared?
I have no idea.
I believe, let's check, 13 squared, 169.
Yeah.
Okay, let's add these two numbers together, my A and B. What is 64 plus 36? 100. Does 100 equal 169?
Nope.
No.
Definitely not. Okay, which one's bigger though, 100 or 169?
169.
So this guy, this time our C was bigger than A and B. So if C is less than, it's an acute. What do you think it is if it's bigger than? Obtuse. So this would be an obtuse triangle because our C side was bigger that time.
Can you just look at the shape?
Nope. The shape will not tell you. If looking at this shape, what would you assume it is right off the bat? I would assume that's a right triangle, right? It's pretty dang close to a right triangle. So that's where we have to use the math to tell us. Is it an acute, obtuse, or a right triangle? Okay, let's maybe do like 2 more. Let's see what you got. Okay, assuming this right here is our right angle, where's my A, B, and C that we're gonna test here? 9 is what?
A C.
What?
8 is a C.
What? If this would be our right angle, what's my C?
15.
There we go. Okay, we'll make 8A, B 9. Okay, we're assuming that angle is our right angle. Okay, let's plug it in and see what we get. Maybe it is the right triangle, I don't know. Okay, we got 8 squared plus 9 squared equals 15 squared. 8 squared, what do we get?
64.
64. 9 squared?
81.
81. 15 squared?
225.
Okay. Oh, that's big. What is 64 plus 81? Come on, Leo.
145.
Nice. His mental math is like so good. Okay. 145 definitely does not equal 225. But tell me, is this an acute triangle where C was less than? Or is it an obtuse where C was bigger than? Carl?
Obtuse.
Obtuse. C was bigger than. Okay. So this guy, our C was greater than, which means this guy is an obtuse triangle. How are we feeling on classifying using Pythagorean theorem?